Hi guys, welcome back to my channel. Today I want to take a look at a question dropped by a Lagos State University students on their continuous assessment on CHM 307 organic chemistry. So I would love to show you guys a bit behind this 307, and if you are as a beginner, this video is for you. And if you're having any difficulties concerning these 307 now, come closer and get what I'm about to drop now. So the first question goes thus, states, name the following aromatic compound, which is the first question from their CA. You have this. This is a first compound. And if we are to name a compound like this, how will you go about it? We all know that NH2 is what? Amine. And one thing about this 307 is that, don't worry, if I will be dropping the mechanism of benzene based on Frederick-Crafts acylation, I will show you the auto, para, and meta, where you can easily deduce your auto as well as your para and meta. So now, if you have to name this compound now, NH2 is amine, based on the video I dropped earlier before. And if amine is combining with a benzene ring, it is called aniline. Exactly. Now, the second structure goes thus. The first thing you need to know when it's come to organic chemistry naming is that you need to know how you can easily identify the functional group. Don't worry, I'll be dropping a video for functional group from alkane down to carboxylic or down to alkanate, which is what? Esters, or more than that. But tonight, let's focus on what we have here based on one of our students in Lagos State University. So we have two. And this particular functional group is known as what? Either we call it alkana or we call it aldehyde. Exactly. Now, so now, and this, it is benzene. So if you want to name it, is not, you're not going to call it benzene anymore. They shorten it to what? Benzyaldehyde, or you call it what? Benzy what? Aldehyde. So let's take it to be benzy what? Aldehyde. We can, if we are to call this thing like benzene alkana, it is correct, but you have to, in chemistry there's what we call IUPAC nomenclature. So now it is called what? Benzyaldehyde. So the question goes though, the third one goes thus. One thing about this thing I come across for this 307 that many students have issues with, it is not the naming I deduce here, it is how a student can easily follow the step for mechanism, because when it comes to mechanism in organic chemistry, it takes steps which you need to understand the concept. So I'll be showing you guys a bit behind that. So after we are done with this naming, so we have another compound here. We have this. We also have the last one, which is here we have OOH. So now, looking at these four things we have on the board, don't forget we say this COH is what? Aldehyde. And now, one thing you should know when it comes to naming organic compound, if you are given a benzene structure, you will consider that irrespective of anywhere you have the functional group, you will start the numbering from where you have the functional group attached to the benzene. So we have this 1, 2, 3. If you are having something like this under the skeleton, this is represented to be what? Methyl. And if we have this, we have what? Ethyl. I made mention of something that I will be showing you guys the auto para person. So here is our auto. Here we also have what? Auto. Here is our para. So this is represented to be O, while this is P. Then here we have metal, and here we also have what? Class metal. So here, so as a student of Lagos State University, this will help you to easily identify the auto para and metal, because we have the activated ring. I also have the what? Deactivated. So I'll show you guys the beauty behind that, but take note of this. So the metal here is placed what? Under the metal. If we are to name this now, 3 is attached to metal, and don't forget the parent's name. If metal is not attached to it, it's called what? Benzene aldehyde. But with metal being attached to this place now, so that 3 will be what? 3 methyl benzyl aldehyde. Some call it benzyl aldehyde. It works like that too, but don't forget the way I picked the naming. So for this now, if we are having this, OH is the family of what? Oxy. Methyl being attached to it, which is CH3, it is what? Methoxy. Yeah, oxy family, but ethyl being attached to it to give us what? Ethoxy. So now, don't forget the rules that for the impact nomenclature of you having a benzene ring, if a functional group is attached to that benzene, again, if a functional group is attached to that benzene, like OH, which is our alcohol, the carboxylic acid, the alkanoates, esters, the alkana, aldehyde, the alkanone, the ketone, you have to start the numbering from where you have the functional group. So now I have 1 here, I have 2 here, I have 3 here, I also have what here? 4. Can you see it now? So we have 1, 2, 3, 4. Sorry, we have 4 here, and here we have what here? 5, and here we have what? 6. If you are to name this compound, you know we always follow it alphabetically. I tell you guys that this O you have here is a family of what? Oxy. So with this, you can say we have 3 ethoxy, 5 methoxy. If you are having a benzene ring attached with COO, this only, it is called benzoic. So without ethoxy and methoxy, it is called 3 ethoxy this, 5 methoxy this, then the ring structure with carboxylic acid is called what? Benzoic. So now, as a Lagos State University student, you should be able to understand the concept of naming, because this is not the only naming you'll be coming across in your examination, but we are only dealing with you are dealing with your continual assessment, which will serve as a guide for your examination. We all know not all what you are given in the CA will come out in your exam, but your continual assessment is serving as a guide for you as a beginner when it comes to organic chemistry. Nothing like you can know it. So sit back and watch this video as I'll be showing you guys some beauty behind the mechanism under this course. So now take a look at this before I will wrap up the board, then we'll continue from there. So now let's continue. So the second question goes thus: write the equation 1AII write the equation and mechanism for acylation of benzene. This carries 6 marks. The first one I did earlier carried 4 marks. That is, each of the structure carries one mark each, and we did it only what 4 structure. So now write the equation and mechanism for acylation of benzene. One thing you should know, there is a scientist that carries this word acylation and alkylation, which is what we call Fredecraft acylation. For every Fredecraft acylation, it contains an acyl group, and the Lewis acid of that is this. Is that clear now? So now guys, the first thing we are going to do is that you should know how to write the equation, and we also asked to show the mechanism for acylation of what? Benzene. So now, if we are to show the mechanism of this acylation of benzene, this is how it goes. The first thing you have to note is, if you are having a benzene, this is benzene plus, I want you guys to look up the Lewis acid will always be here, and we have this. This here will be attacked by, if one of this is being attacked by X, we'll be having plus HX, and we have what? HR. Now let's take a look at the steps, and the steps we talk about here, we are dealing more of the what? The mechanism. So the first one is step 1. So if we are given step 1, we're playing with isopropyl chloride. So now this, we have this. What we have here is isopropyl chloride. The catalyst is our Lewis acid of that acyl group. So now it is very what? Simple. Looking at what you have here, class. Looking at what you have here, Al here, and this Cl3. This one here is going to what? Attach itself to this. And don't forget that this is a what? A negative, more of a nucleophile. So if this is living here, we'll be having a positive sign here. So we are going to write this now, and for us to have added chlorine to this place, we said we have CH, CH3, CH3. We are having a what? A positive sign here. Plus this one here is AlCl4. Initially what we have here is what? AlCl3. So this is the first step. And one thing about the secret of mechanism of any organic compound is that what you are having as a product here, if you are to start the second step, you have to bring the product here to this place. Are you with me? So now we have our step 2. And for this step 2, don't forget we are talking about the mechanism of what? Benzene for acylation. So now we're going to introduce benzene here now. So by doing that, we have this. So we have this, we have this, and we have this. So this product you have here now, we take it here. Why this will be acting as a catalyst? So with that, like I said, plus CH3, positive sign here, C what? CH3, shall have this as our what? Catalyst. So with that now, what you have here now, this H here is going to attack here. And don't forget that what you have here is the same thing as this. There's what? H here. H is A, H is A, H is A. We also have what? H here. So for you to have added this here now, it's going to form what we call an arrhenium. And what is an arrhenium? An arrhenium are those nucleophile being attacked by an aromatic ring, or we can say that it is the formation of an attack to a benzene ring. So that is what arrhenium. If this thing is coming here now, we are going to form an arrhenium. That is, this one here will what we left out there. So for you to have an arrhenium, this is the structure of what arrhenium. This is the structure of arrhenium. So having a positive sign here, and for you to have that arrhenium, you know our H here is not showing initially from the structure of the benzene, if you are to have it in this form. But if you are to show it in the structural formula where we'll be showing before we have something like this, so this thing is not here initially, so you have to what clean it again. What you have here is this is the benzene. So for this positive sign here to be attacking this particular double bond here now, we are going to form what we call arrhenium ion. And with that, I can say here, this particular place here that it is attacking, I said I have H. Then what you have here, I'm going to place it there. So you can say you have CH, which is this. Then your CH3 is still there. Is that clear now? So this is how I'm going to show the mechanism. So let's take the last steps. So we have step 3. And for that step 3 now, what you have here, you are going to place it here back. If you observe vividly, if you see, this double bond here is not here again, because this thing is this electrophile here coming into this place is going to attack this to give us what? Arrhenium ion. So you are going to have what you have here as a product. As I've said earlier, that for every mechanism, what you have there as a product, you are going to use to start the next steps. So with that, so I'm going to rewrite this. So I said I have, please pay max attention to this. It is very, very important. Having our arrhenium, then we have H, CH, CH3, C what? CH3. So this thing we have been acting as a mechanism now, plus AlC4. So now we want to form our what? Acylation of what? Benzene. So guys, looking at what you have here now, we can easily split this to be Cl, Cl3. We are going back to this because we said acylation, ferric acylation is the formation of having what? An acyl group, and this AlCl3 is acting as a what? The Lewis acid there. So with what you have there now, this one here, okay, let me make use of another marker to show you guys this. So this blue marker now, this H here and this Cl here will react together. With that, we have what? Plus HCl, and we are left with what? You know, initially this here is going to what? React with this. So we have plus AlCl3. So guys, exactly now. So I'm going to write this now, and if you have to write this, nothing like arrhenium again, because this H is what? Leaving that benzene ring. So you can say you have this. We have this. So you can say our CH is here. So CH3. Please take note of that. So I have to, let me write this so it will be clear to you. So the benzene ring is there. Our CH3. So now, if we have to name this now, initially I said we started with what? Isopropyl chloride. So this is C the what? The isopropyl. So this structure is what? Isopropyl benzene. Exactly now. So for every equation or for everything that deals with mechanism, the first thing you need to know is that if you are talking about acylation, these are steps. So I'll be dropping another video tomorrow to explain the concept of alkylation. So guys, don't forget to subscribe to my channel, like, as I've showed those students at Lagos State University the beauty behind 307. Fear no more, even if you are what, a beginner. Is that clear now? Thanks.